Identify the first mechanistic step in the reaction shown below. So in order to identify what the mechanism is and draw that first step, we need to look at what we're being given in this reaction. So we see that we are starting with an amide, and our products are a carboxylic acid, and this would be considered the major organic product if you were asked about that. And you're also getting the ammonium salt. And so I'm calling it a salt because there would be some counterion in there depending, and what counterion it would be would depend on what acid you use to generate your H3O+, right? For instance, if you had used hydrochloric acid, this would be an ammonium chloride salt. So we want to think about the mechanism. So all carboxylic acid derivatives can be hydrolyzed to give you carboxylic acids. And your less reactive derivatives like amides need to be forced a little bit. Just reacting these with water is not going to be sufficient. So these are some of your less reactive carboxylic acid derivatives. And so for your less reactive derivatives, just water isn't going to do anything because this carbonyl is not very reactive. Water is not going to just attack it. So what we're seeing here in A with water just attacking a neutral amide is not going to happen because the neutral amide is not reactive enough. So that's why we have in here, instead of just neutral water, we have acids. We see that we have acidic hydrolysis conditions. And so when you have acid catalyzed conditions with a carbonyl, the first step is always going to be protonation of the carbonyl oxygen. Right? It's by doing this that we actually catalyze the reaction and allow it to take place. Without the acid catalyst, if we were just to try to use a neutral amide and neutral water, we have a not reactive electrophile and we have a not reactive nucleophile, and the reaction simply won't occur. So if you're using acid, you're going to first protonate the carbonyl oxygen. So that is going to be what our first mechanistic step is, and we just need to know the identity of our acid. And so the acid that we have in this case, right, if we have H3O+, then we have H3O+ that is available to act as the acid in this reaction. And you also have the conjugate base water, which is available to act as either the nucleophile or the base in this reaction. And so if you have H3O+ as your acid and you need to protonate the carbonyl oxygen, this option here, C, is going to be the first mechanistic step. So after you do that protonation, this is what you're going to have, right? And so this carbonyl oxygen is now more electrophilic. That's the role of that protonation. So now in the second step of the mechanism, now your water, which is still a weak nucleophile, this can attack that carbonyl carbon, but that can only happen if you've made your carbonyl carbon more electrophilic by protonating it. And then this would be your second step of the mechanism.